Hey everyone, and welcome to my talk in Espressif DevCon 2020 something. And today we are going to talk about something quite revolutionary, about taking your hardware, your beloved ESP32 dev board, and running it in simulation in the browser. So you can take your projects and prototype them without having the real hardware. Not only you can prototype without the real hardware, you can also easily share your hardware projects. And if you want to teach something using ESP32, then that's also like a great opportunity to conduct teaching sessions without having a lot of hardware and worrying about shipping and export and all that stuff. So let's talk about Wokwi. And first surprise for today, there are no slides. We are all going to see a lot of like demos, but there are going to be no slides. So I prepared a document. You can open this link later and see all the links with all the demos that I'm going to show today. And I think the first thing we are going to do, we are just going to get out of those slides because we don't need them anymore, and open the simulation homepage, wokwi.com. That's the simulator, and there are like a bunch of demos on the homepage. But I want to show you, usually when you show hardware demo, you start with Blink, but I think like Blink is overused, so we are going to do something a bit more complicated. We will start a new ESP32 project. So this is like the Wokwi workspace. Let's make the font a bit bigger. That's a hack to make the font bigger. So you can easily see the code, and we have like an ESP32 board and Arduino code that runs on this board, and as soon as I hit play, this code is compiled and you can see the result. But I promised something a bit more interesting than just hello world, so let's add this temperature sensor and start making the connections. I press G to get a nice grid, so it's easier to connect the stuff. And let's connect the VCC pin, the ground pin, and also the data pin for this DHT22. DHT is digital humidity temperature sensor. 22 is like the precision or something like that of the part number. So now we have got a sensor wired, and in order to talk with the sensor, we need to add a library. So we are going to use this DHT library for the ESPX. And by the way, if you click on a part like this temperature sensor, there is this question mark, and when you click on it, you go to the documentation where you can find all the information about the pins of the parts, usage examples, how to initialize it, and you can even see there is like a note about the ESP32 that tells you that this is the recommended library. So if you want to use this DHT sensor with the ESP32, then use this library we just used. And now that we have this library in the project, we can include it. So let's include DHT ESP.h, and then we can define a constants for sensor pin. We connected it to pin D15 here, so that would be pin 15. And we can define an object of DHT ESP with the temperature. So we call it like temp sensor, and then we can initialize this by calling temp sensor dot setup with the pin, so that would be 15, and we also need to tell it like which kind of DHT sensor we had, the DHT22. And finally, we finished initializing everything. We can just move this line, and instead of printing hello ESP32, we can print hello and then add a temperature. So temp sensor dot get temperature and humidity. It also has like humidity info, and then we can just print the temperature. Let's add a new line so it's a little bit easier to see what we did here. And finally, we'll add a small delay so it doesn't flood our serial console. And let's see if our not blink, not hello world example worked well. So I'm going to hit play now. It's compiling the project. That usually takes a few seconds. And yeah, I needed to convert the temperature into a string. So let's do that, string with 2 decimal points. And let's compile it again. And whenever I hit play, this code is sent to a cloud service that compiles the code and then downloads the binary file, the compiled firmware into the browser for the simulation. And now we can see it's running, it's printing a low 24, and if I change the temperature to something super high, like 42.2 Celsius, you can see like it's printing the new temperature. So yeah, this is how you prototype with Wokwi. Just add components, install any libraries if you need, and write your code. We can even make it a bit more interesting by adding another like 7-segment display. So let's add a 7-segment display and connect the pins like we did before, ground and power. Where was that? Yeah, power. Let's connect it. Yeah, it tells us where to connect it. And then we have also this data pin. Let's connect it, I think, here. 12, doesn't really matter, we can define those pins in the code. And I have a small code snippet that includes, adds this display. So let's first install the library. There is another library for this part. It's called TM whatever tiny display, and we can paste the code. And this code is very similar to what we had before. It's instead of printing the temperature to the console, it just shows this temperature on the 7-segment display. So as I'm going to hit play, the code is compiled just like we had before. And once the compilation is finished, we hope to see we can now see the temperature printed on this 7-segment display module. So that's the idea. You add your components, connect them, you write the code, install any libraries that you may need. You can use this library manager or just this text file. And once you are happy with what you got, you click on save. And voila, you can see this, you have this link and you can share this link. I will share it with you in the document, but you can share this link with whoever you want on the internet, and all they need to do is just to paste it into the browser, click play, and they can start tinkering with what you just created with this project. So that was a quick introduction to show you what we can do, but this is only the tip of the iceberg. Other than connecting sensors and interacting with them, I think the most the ESP32 is mostly famous because of its very useful feature, which is Wi-Fi, and you can use the Wi-Fi to create IoT projects. And I think the next thing we will see is, let's close the docs, is ESP32 plus Wi-Fi. So this is another piece of Arduino code that you can see here if you are familiar with NTP, that's the Network Time Protocol. You can see it's connected to this NTP org server, and it downloads the current date and time. And in this simulation, we are using a different display module, the LCD1602, using the Liquid Crystal library. And what this basically does, it just initializes the LCD, prints connecting to Wi-Fi, then it starts to connect to the virtual simulated Wi-Fi. And once we are connected, it will update the time and display it every 250 milliseconds in the loop. So print local time goes to, calls the get local time function, and then it prints the time on the LCD display. By the way, that's a cool thing of the LCD library. It has like a specific method, a specific version of println that can print time structures. So let's see this in action. And now we are running the simulation. It's connecting to the Wi-Fi. You can see it got an IP address from the virtual Wi-Fi server. And we have a connection error. So embarrassing. Let's try that again. I wonder why we have a connection error. Because it's a live demo, of course, then the NTP server is down or something like that. Yeah, let's try that one more time and see if we can figure this out. Yeah, it does. Oh, yeah, it worked third time. So not sure why it had twice connection errors, why the NTP server had not worked while doing the demo, but you can see that now it works, and we can see the current date and time on the LCD screen. And you probably wonder what's going on here. Like, is it really connecting from the web browser to the internet? How does that work? And we'll talk about that in a second. Let's see one more demo with IoT. This time, instead of using the NTP protocol, we are going to use the HTTP protocol. And this is another example. You can see it connects to this server. That's a joke API that gives you a JSON joke whenever you connect to it. And then it does some parsing. It's using the Arduino JSON library. You can see here we are using Arduino JSON and this other library to control the display. And it prints the display, the joke on the display. So when we start it, you will see it says that it's connected to the Wi-Fi and prints the IP once it's connected. And then it will start printing jokes whenever we press this button. So let's see this in action. Let's hope that this time the internet will work well. So it's connected and you can see a joke. Unfortunately, it's a bit long joke, so it's cut at the end. Let's get a new one so we can see the full joke. Can we get a new one, please? Yes, perfect. And yeah, you can see, oh yeah, kerning joke. If you are familiar with fonts, you will understand this. We messed up the kerning again, guys. So how does this work? How does this simulation connect to the internet? So I'm going to tell you what's going on behind the scenes. So behind the scenes, this is actually running a virtual access point, and the ESP32, the simulated ESP32 connects to that access point and sends Wi-Fi frames to this access point, and those Wi-Fi frames are then forwarded from your browser. This whole thing happens in your browser. They are forwarded from your browser into an IoT gateway that we run on Wokwi.com, which takes those and sends them to the internet, and then it gets the responses from let's say this joke API dev, and it sends it back to your browser as Wi-Fi frames. And we are going to see an example of it soon. But first, let me show you another cool feature of the simulator, because we have seen some Arduino examples and we have seen how to interact with the virtual Wi-Fi and connect to internet servers. But what we still haven't seen is that you can also do this with not only with Arduino, but also with other programming languages like MicroPython. So I think this is my favorite demo with MicroPython. Oh, sorry, this is not with MicroPython. This is my favorite, one of my favorite demos with MicroPython. It's simple and it includes a complete IoT project, as I would call it. It's again the ESP32 with the same sensor we have seen before, the DHT22 temperature sensor. And you can see the code now is written in Python. And when we start a simulation, the ESP32 will actually load MicroPython, the MicroPython firmware, and then it will use this MicroPython firmware that it loaded to run this code from the virtual flash on the ESP32. And this MicroPython code connects to an MQTT server, which we will see in a moment. And then when you are connected to the MQTT server, it sends the temperature data. You can see here, it is reading from the sensor, and whenever there is a change, it sends it to the MQTT server. So before running it, let's just open the MQTT client. So that's MQTT client for the web. And let's just fit the simulation into view. We can actually hide the code because we don't need it right now. We have looked over it. And now we are going to connect the MQTT client to the MQTT server and subscribe to, yeah, I said I won't need the code, but we do need it to subscribe to Wokwi weather. Yeah, that's the topic that the code uses. And we can see we are subscribed, and now we can start a simulation. And when it connects to the Wi-Fi, we should be able to see it. It sends a message. Let me make the font a little bigger. It sends a message to the MQTT server with the current humidity and temperature. And of course, if we change the parameters, we will get even more messages. So this is like the simulated ESP32 running this MicroPython code that connects to the MQTT server and sends messages. And I think this is a good opportunity to actually look into this implementation and see what happened behind the scenes when we send those MQTT messages. So I'm going to press F1, which opens the secret command menu, and then I'm going to download Wi-Fi package capture file. And this file will include all the Wi-Fi data that was exchanged between the ESP32 and the virtual access point during the simulation. And then if I open this file on my computer, I can actually see that there are all these, I don't know if I can easily, oh yeah, I can make the font larger. There are all these like Wi-Fi frames that were used. So those all probe request, response, authentication, association, all this part was just connecting to the Wi-Fi. And then we have like all this DHCP stuff, which is how the simulated ESP32 got its IP address and DNS configuration from the Wokwi IoT gateway. And once it connected, it actually sent a DNS query to look up the address, the IP address of the MQTT broker. And as soon as it got the address of the MQTT broker, it started like doing MQTT. We can right click and follow the TCP stream to see all the like MQTT data that it sent, like all those JSON that it sent. So this really shows you how the whole things work behind the scenes. It's in the packet level that is like the simulator is actually sending and receiving Wi-Fi frames, and those are then sent out of the browser into a proxy. And this actually lets you see all the implementation details of all like the Wi-Fi and the TCP/IP protocols, whatever simulation you are using. So if that was a bit too technical for you, that's okay. It's pretty advanced networking stuff. But for those of you who do have some experience with networking, I wanted to show you how this whole thing works behind the scenes. Just like this demo, we have another cool demo, which is, I will put the link, you can try it yourself. It's an ESP32 connected to a bunch of NeoPixels. And then you can use the same MQTT server to send it messages and change. You know what? We already have like the MQTT connection. So, or did I close it? I think I did. Let's do a real quick demo. So put this one to the right side, this one to the left side, connect, and then we can just publish a message. Let's do this demo. And publish to this demo topic, and as soon as I publish, you can see like the Python code here got the message and updated the colors. You can try another one just for the sake of it. So just another cool demo. This way it's the other way around. Instead of sending messages to the MQTT server, we are listening to MQTT messages and acting accordingly, updating the LEDs in this case. So that was another cool demo with MicroPython and MQTT. And I think the next thing I want to show is just a it's nothing very new or something you haven't like seen before in terms of what a simulator can do, but I just love this because this is something that a user did. It's an ESP32 control connected to 3 OLED displays. And what I love about this is that he used a very creative method of connecting the displays to the ESP32. He used 3 relays, so he could control each of the displays individually, even though they are all connected to the same I2C bus. So they are all connected to the same I2C port, those 2 pins. They all have the same address, but as soon as the simulation starts, you will be able to see that each of them is updated individually. And we are not going to go over this code because it's pretty long, but if you want, I will share the link so you can dive into it later and see how he uses like the relays to switch the I2C bus to different Adafruit displays and control them individually. What I do want to focus on next is showing you another cool, from my perspective at least, IoT demo, which is this one, the ESP32 IoT server. I said we won't have any blinks, but it's not exactly a blink, but it's pretty similar. So sorry if you expected to see no blinks, you will see one now. So this is a simulation of an HTTP server running on the ESP32. And it has one API endpoint called /toggle that toggles an LED. It gets like one of those 2 LED indices, the blue one or the green one, and toggles their state. You can check out the code later, but it's basically just toggling the state and doing digital write to update the state of the LED. And let's run it. And once it's running, we can open another web browser to connect to the HTTP server running in the simulation. So yeah, I got another web browser here and it connected. You can see this is like the web page that is sent by this small web server, a simple HTML file with 2 links for the LEDs. And as soon as I click on one of those, you can see like the HTTP server is getting and handling the request. So you can also use Wokwi to simulate servers, not only like client IoT applications, but also like projects that use HTTP server or other kinds of servers. And now we are going to blink the LED a few times, just as any proper hardware demo has blinking LEDs. Cool. And while talking about blinking, that reminded me, we have seen like some MicroPython demos, but there is something else that I want to show you, something that I love about MicroPython. And for that, let's just start a new MicroPython project and add an LED, and not the LED matrix, sorry about that, just a standard LED. Flip this LED with P key and set up the grid with G, and let's say connect it to D2 and to the ground. Okay, so that's an empty MicroPython project, and if we start it, it prints hello ESP32. The font is a bit smaller, so I will try to make it a little larger. It prints hello to ESP32 and the program finishes, so we get to the MicroPython console. And what I like about this is that we can see how powerful MicroPython is. MicroPython has this machine module which allows you to talk directly with the hardware. So for instance, we can use the hardware registers that control the GPIO port for the ESP32 to control the LED. So another type of link. And we are going to do it, first of all, by running some magic values to some very spatial memory addresses. You don't really have to know about these memory addresses. Again, this is pretty advanced stuff, so if you don't know, it's totally fine. But this address sets pin number, writing to it sends a given pin to output. 4 hexa means pin number 2, that's bit number 2. And then if we write to a different address, this will actually set a pin to high, turning the LED on. And we can also write to another address, this one, to turn the LED off. And you can easily see how we could create a loop that would blink an LED, but I promise no blink program, so it won't be a blink today. That's one of the things I really love about MicroPython. It's simple on one hand, but when you need to get like raw access to the hardware, you can do it just like we did today. And since Wokwi actually simulates the entire ESP32's chip with all the instruction set and all the peripherals, or most of them, you can use this interface to actually learn about the internal peripherals and hardware of the ESP32. By the way, talking about the hardware, there is, in the Wokwi doc site, there is a nice guide for the ESP32. So if you go there, there is a table that shows you which peripherals are there and which are not. And we are adding new stuff all the time, so if you need something, I will show you soon how to create a feature request so you can get it. But you can see that we support the ESP32, ESP32S2 and C3, and there are a bunch of peripherals that are already working and you can use. So yeah, so that was just another piece of fun fact about the powerful features of MicroPython. And other than using Arduino and MicroPython, you can also use other runtimes. This is just an example of using the ESP-IDF directly. So it's a simple, or simple if you use the IDF. If you have never used the IDF before, it's not so simple. It's a code example that creates 3 tasks, red, blue, and green. Each task has a different LED that it controls, and there is like those parameters that tells the task which LED it controls and how fast to toggle it off, on and off. So you see we are like using different rate for each LED, so it's not going to be just the standard blink. I promise there won't be standard blink, but it's going to implement some sort of binary counter with the LEDs by running those 3 tasks in parallel. This is the implementation of the task. And again, I don't want to go into the specifics of the code because I realize that many of the people here are not very familiar with FreeRTOS and the IDF, so I don't want to confuse everybody, but you can see this is like what the code does. And the purpose of this demo was to show you that Wokwi can also run ESP-IDF code and not just Arduino and MicroPython. And there is even more. We have been working very closely with the Espressif Rust team to let you run Rust code on Wokwi. And there is wokwi.com/rust with a bunch of examples that we created. Let's take a look at this crispy click. It's a simple but nice one that I like. And let's increase the font size like we did before. And this crispy click, as you can see, is implemented in Rust. So this is the Rust language. If you haven't heard about it, there is a great talk from Scott Meben about running Rust on Espressif chips. So do watch it. And this has like a lot of code. We are not going to dive into it. I'm not Rust expert either. I couldn't write this code myself. Thanks for the nice people from Espressif, I think, provided this example. But I just wanted to show you that we are also like able to run other programming languages like Rust. So I will have the link, and you can also go to wokwi.com/rust and play with this later if you want, or if you are into Rust. There are also a lot of other interesting things you can do with Wokwi, so I will just show you some of the things we are working on right now to see if any of you is interested. You can jump on to our Discord community and help us prototype them. So this is one thing I'm extremely excited about. It lets you, our users, define your own custom chips or custom logic that goes, sensors or whatever that goes into the simulation. So this is one example created by one of our users. Let's see if, no, that user didn't write, he just used the template, so it has my name, but he didn't write his own name here. Yewolf, yeah. So this is the user who created this. And we have a keypad in Wokwi, but Yewolf needed something else for his project. He needed a keypad with an I2C based controller chip. So instead of having the code that scans the keypad run continuously on the ESP32, he had some chip in his project. I don't think he wrote here what the name of the chip was, but he had some board or breakout board in his project that scanned the keypad from him and exposed the information about which key was pressed over the I2C bus. And we didn't have this chip on Wokwi, and now we have, because that nice person, Yewolf, wrote it as a custom chip. So custom chip is a new API we are working on that lets you define your own chips, and you define the pins in a JSON file, and then you define the behavior in a C file with the API that we provide. And the cool thing about it that as a user, you just use it as if it was a physical part or an actual part, not a physical, simulated part built into Wokwi. You can see that it's using here a standard I2C keypad library that talks to this chip and gets the data from this chip. So if you press some key, it goes through the chip decodes this key, and then sends this key to the ESP32 over I2C. And I think this is really powerful, because now you are no longer limited to just the parts that we provide, but you can create your own parts. Another cool example is this user who implemented his own LM75A temperature sensor. I think this was Anderson Costa from Brazil who did this. And again, it's an I2C temperature sensor, and there is a JSON file that defines these inputs and all the pins, and the C file that defines all the code. And if you are interested in that, let me know. There is new APIs coming to create custom displays. If you wanted to create an e-paper display or custom LCD display, you will be able to do it. APIs to interface with SPI, UART, I2C, all the common protocols. And I know you can ask for other stuff. That's why it's a prototype, to get your feedback. So that's one cool thing that is happening with Wokwi. Another cool advanced use case that I'm working on right now is a command line version of Wokwi. Don't know if it's going to be public or not, but if you are interested, let me know. Let's do a quick demo. So this is the command line version of Wokwi. Let's make the font a bit larger. And I'm telling it to simulate the ESP32 C3 to load these bin files into memory and run the simulation. And as soon as I hit enter, you can see this is the hello world example from the ESP-IDF running in the simulator in the command line. And there is another demo here where I run not this, Wokwi ESP32 row input, and then there is the MicroPython firmware. So I'm going to load the MicroPython firmware and row input. That wasn't it. Just hold on, it's too new, so I still don't remember the syntax. It's probably input row, yeah, right, input row. So yeah, so this time it's going to, well, it's perhaps too new, so oh yeah, it worked, yeah. So I got the MicroPython REPL on the simulated ESP32, but this time it's machine that just bring the frequency of the CPU. This time this is running in the command line, and you can imagine how this can be useful running ESP32 project simulation in command line for continuous integration use cases or automated testing. So if you are interested in any of this, drop me a line on the Discord and let me know. And before we say goodbye, I wanted to show you just one more cool feature of the simulator, which is also useful for debugging. We had this demo we created with a DHT22 sensor, but what happens when things doesn't work? So for that we have this logic analyzer, and you can connect it to any pin in the simulation. For instance, in this case, we are going to connect the logic analyzer to the data pin of the DHT22. And the logic analyzer is going to record everything that is happening on this pin. So when we start a simulation, we can see the amount of data it recorded, and we can also see like, let's change the temperature to very hot. We can also see like this activity LED blinks whenever there is activity. But the cool thing is when you stop the simulation, you can actually open the recording file. I'm using a desktop software called PulseView to view this file, and looking at it, I can see the signals and their exact timing to the microsecond, even nanosecond accuracy of the signals that went on the wire that I recorded. And actually, if I wanted, I could ask PulseView to just decode this data for me. So just by some configuration, we can see like PulseView can decode these bits and show me the values that went over the wire. So this is super useful when something doesn't work, so you can see if there is activity on the wire, and if you are using the I2C protocol, for instance, you can see all the I2C messages and responses. I didn't want to show you that because that's usually a lot of data, and what I like about this DHT demo that is, it seems a lot of data when you look at the raw recording for the input pin, but then when you look at the decoder, it starts to make sense because there are just a few bytes of data, humidity, temperature, and checksum. So this is one of the tools that I use myself when I debug things that don't work on Wokwi. We do have like a way to submit bug reports. And the first thing I do when there is a bug report, I usually just take your project, hook a logic analyzer, and see if the pins are sending the data, any data, if they are sending the correct data, and that's how I debug. And one extra thing I wanted to show you, it's just something cool I discovered when I was working on Wokwi. So that's the ESP32. And apparently the ESP32 had some secret tiny basic interpreter buried into the boot ROM. And when you start a simulation here, this is just an Arduino code that jumps into the tiny basic inside the ESP32 boot ROM. I found the address by disassembling the boot ROM, and it calls this. So when we start the simulation, you can see this, just let's zoom in a bit. Yeah, you can see this basic interpreter. Now, I'm not very expert in basic, but I did learn a few commands. So if you type about, you can see some information. There is also help, print hello world, of course. And there is IO set. So IO set, let's set pin 4 to output, and IO gear, let's set the direction to output, and IO set it to high. And we can just play with this pin. So yeah, that's just something cool that I learned while working on the ESP32 simulator, that you had this hidden basic Easter egg in the boot ROM of this chip, and if you want you can play around with it. There are like for loops and all of that stuff if you want, if you are like into basic. I'm not so much, so you can check it out later. I'll include the link to this project as well. And before we say goodbye, Wokwi is already able to do a lot of things, but we keep getting requests and adding new stuff. And one of the things we are working on now is adding the new ESP32 S3 chip, which is quite popular. It has some AI capabilities. As well, we have like this roadmap where you can see wokwi.com/features. You can see the next things we are going to work on. That's things that users suggested. So if you have a suggestion, you can just click here, open an issue on GitHub, and let us know what you need. You can see that the interactive debugger is on top. This is what we are working on right now to let you add breakpoints, step, watches, all those stuff inside the code editor across all the platforms. So ESP32, Extensa, RISC-V, and AVR and ARM that we also have on Wokwi. And if you love any of those features, like if you wanted to have I2S on the ESP32 or resistor divider simulation or a breadboard, which is apparently not popular, but not as much as I expected, you can buy vote powers and vote for it by clicking on this button. So this is where you can not only see what's coming next, but you can also affect on what's coming next. So that was a really quick overview of Wokwi and what it can do, and hopefully how you can use it for your projects and some of the advanced capabilities like the custom chips, logic analyzer, the Wi-Fi packet dump, and the maybe upcoming CI integration. There is one demo I forgot to show, but it timed out, but it's a really cool thing that the Rust team has been doing. This is also like using Wokwi inside GitLab or GitHub workspaces in your cloud projects. If you want to hear more about that, just go to the Discord server. There is like the link on the homepage, and chat with us. Maybe they will also show it in one of their talks. So do check out all the other talks in the conference. So I would love to get your feedback and learn how to make, how you find Wokwi and what you use Wokwi for. So feel free to join the Discord community and share your projects. And I hope that you enjoy this. Thank you.